Welcome to 2.1. In this lesson, we are going to learn about all things quadratic. So let's start with some vocabulary. You should know all these words, but just in case, we'll review them. So here is our basic parabola, our basic quadratic, our basic x squared function. A couple of things about a parabola. A parabola is always going to have a lowest, or if it's flipped around, that's the highest point on the parabola. That highest or lowest point is called the vertex. Another thing, next we have what we call the axis of symmetry. Basically, it's the mirror in the parabola. So you can see that this whole parabola is mirrored across this blue line. So that blue line is called the axis of symmetry. And hopefully you'll notice that this axis of symmetry will always go through the vertex, because the vertex is centered in the parabola. We always write our axis of symmetry as x equals a number, and that number is actually always going to end up being the x value of the vertex. Okay, a couple other things that we always find. We always like to know what the x-intercepts are and what the y-intercepts are. In this one, they're the same. That one is an x-intercept and a y-intercept, but it can change. So now that we know all four of those things, let's briefly go to example 1 and do a transformations review. So this is a transformation of my parabola. I have a +2 on the inside, so that means it's going to move left 2, because inside is always opposite, and left and right. And I have a -3 on the outside, so that's going to be down 3, because outside is always the same, and up and down. So I'm going to take my parabola that I started with, that I had just up above. Here, I'll copy it here in dashes. And I'm going to move all the points of this parabola left 2, down 3. So we have left 2, down 3, left 2, down 3, left 2, down 3, and we keep going till we have them all there. So this is our new parabola. Now, next, we're going to practice naming all those vocabulary words we just learned. So I like to call them the big four, because they're the four main things you find with every parabola. You have the vertex, the axis of symmetry, the x-intercepts, and the y-intercepts. So let's just get a start here. Let's start with the vertex. So I notice that's the lowest point on the graph, so that's going to be that one, and that is at -2, -3. So there's my vertex. And wait. Before I move on to axis of symmetry, -2, -3. Aren't those the same numbers that were in our transformations? Except this one gets flipped because since it's inside, we always do it opposite. That will actually always hold when your equation is written like this. This is called vertex form. It's called vertex form because it's really, really easy to find the vertex when it's written this way. Your vertex will always be opposite sign of that number, comma, that number, and that's your vertex. Which also makes our axis of symmetry pretty easy, because we always know axis of symmetry is x equals, and it's always the x value of the vertex. We can see right there, that's halfway through the parabola, so at -2. Same. So when you have an equation written in vertex form, it's really easy to find the vertex and the axis of symmetry. Now let's move on to my x and y intercepts. My y-intercept is pretty easy. That's where it crosses the y-axis at 0, 1. However, my x-intercepts look like they're probably going to be decimals, which is kind of hard to see on a graph. So basically what we're saying right now is vertex form is not very helpful to find our x-intercepts, and usually our y-intercepts too. So instead, we have another form, and this form is called standard form, and it is really helpful for finding these two things. So let's talk about standard form real quick. Standard form is if you take your vertex form and actually FOIL it all out, multiply it out. So I got my squared, times it by itself. Now we FOIL, we distribute. To get that. And then I can combine like terms, and I get that. So this is the exact same equation as this, except this is all multiplied out. So this is my standard form when it's all multiplied, and this is my vertex form. So now, if you look at standard form, it's really easy to find the x and y intercepts in standard form. By the way, quick reminder in case you forgot, x-intercepts happen when y equals 0. Y-intercepts happen when x equals 0. So if I take my standard form and I set all the x's to 0, you'll notice my y-intercept is really quick to find. It's 1. And that is exactly what we got up here. It was 1. So you'll see pretty quickly that if your equation's in standard form, your y-intercept will always just be this last number, because these will be zeros and they'll go away, and all you'll be left with is that one. So that's why standard form is really nice for y-intercepts. It's really quick to find that 1 and have your y-intercept. Now, x-intercepts, we have two methods. We can either factor, and preferably you always want to factor if you can. If you can factor it, everything will go better for you. If you can't factor it, your backup method is the quadratic formula. And in this case, we can't factor it. There's nothing that multiplies to 1 and adds to 4. So we would have to do the quadratic formula on this. So right here, this summarizes everything we just talked about. We have our two forms. That one, this is not general form, is vertex form. And this one, which is, oh, I got those totally mixed up. This is my standard form. There we go. Sorry, guys. And this is my vertex form. So, once again, summary. Vertex form is good for finding your vertex and your axis of symmetry. Your standard form is good for finding your x-intercepts and your y-intercepts. And then right here, we have your quadratic formula, just in case you have forgotten it. You will want the quadratic formula memorized for this class. We're going to use it a lot. If you remember like the little song, if you memorized it with a song, that works. You just need to know it. So, in the next video, we're going to talk about this quadratic formula a little bit more and how we use this quadratic formula to find our x-intercepts, which are also called our zeros or our roots. That is the point of the quadratic formula, and we'll talk about that more in the next video.